Okay, so welcome back to the shop. I know today's world there's a lot of cordless tools available, a lot of things out there, but not everything is cordless. So I had an idea to come up with something that would make a cordless tool sort of out of corded tools. At least get a portable power source. And here we can see we're plugged into this PACKOUT container. So let's get into what we did here and see how we made it. So let's just take a look around this thing. Now that we got it made, we got our power inlet. This is how we're going to charge everything. We got 2 power plugs. There's one here, one here. We got our control switches. This one here, which controls the inverter. You heard it just turn off there. We got this one here, which manually turns on the outlets. That'll be what puts power to these. And then this one is for charging. That gets power to the charger inside to charge the battery. Regular PACKOUT in the handle area there. Now what we have here is our USB charge. And then here we have a regular 12 volt car style outlet, and we can test that. Got a Harbor Freight work light here, and we can plug this in and hopefully we will get some indication that this thing is indeed charging. There you go. We turn that off and our charge light goes out. So there we go, we got that working. And then also here is another 12 volt outlet, and that's a heavier, it's actually a 250 volt outlet, an old school 250 volt outlet that has no ground, but we're using it for a 12 volt outlet, and I'll show you what that's for. So a long time ago, Milwaukee actually made 12 volt corded tools, and this happens to be one of them. And I just kind of wanted a power supply to be able to run the tool and play around with it a little bit. So let's see if this thing runs. Runs good. It's, you know, it's not like your cordless tools. These old tools have a little bit different running characteristics. You notice they take a little while to spool up. And they coast to a stop. But all the same, this is neat old stuff. And I wanted something to power the tool with. So that's my own use of the of everything there. This is a 3 amp drill. I don't know, you know, it's probably got some thick grease in it. It's probably not gonna, might draw a little bit more, a little bit less, but put a little load on it, it's fine. This is designed to be in around the 3.5, you know, 4 amp ish range. It's not a high current design. Okay, so in addition to that, we also have, for my own purposes, this isn't really the ideal use of this, but we'll just use this to illustrate. We installed a remote, and that will control these 120 volt outlets. So let's push on here, and I'll push off, and then we'll talk about it. So our remote works well. So it's a little hard to get here, but you can see we got 13.1 volts, and there's our USB connections. Kind of nice, 2 amp charger. And we got the little rubber dealy there to help protect everything. Turn it off. So here's our 12 volt plug, standard 12 volt plug. Plug anything that you regular get in. We have this fused at 10 amps. That should be the working capacity of this particular model. That's why we went with that, and that should work out pretty good for us there. And here is our old school NEMA, I forget what it is, 220 or something like that plug, and that will, here's our switch for it, turn it on off. This is for our old school Milwaukee tools that are 12 volt, so that just gives us a good way to run them. And you know, also I'm going to use this plug system for, you know, 20 amp outlet of plug. So we have 60 amp hour battery capacity in here. We should be able to run some of this stuff a little bit at a time. I think I figured out my anticipated 500 watt inverter runtime should be around 2 hours. So without going into too many painstaking details, everywhere I bolted something to this thing, I strategically placed it and countersunk the bolt heads so that they're flush with the PACKOUT, so that it can go on top of other PACKOUTs. The thickness was good enough to do that. It's not super thin and it's not crazy thick, so I mean, it's plastic, it drills easy anyway, but that worked out pretty well. And here you can see the bottom. There's actually, you know, a nice 3/4 inch gap or so. It works out really nicely to have airflow for those fans. So that's another nice part of doing it this way. Okay, so let's take a look at the inside of this thing, right? So I went with 2 lithium iron phosphate batteries. They're both 30 amp hour and they're hooked in parallel, so we're 60 amp hour. I have a 500 watt inverter in here. I really went with dimensions of things that would fit inside the PACKOUT. That's one of the things that was kind of limiting me on what I could do. I wanted to go with this size case, so I didn't want to go too big with everything, and you see I kind of shoehorned everything in here. So first off with the batteries, went through distribution blocks. They're just automotive style things. And then we fused everything. We fused everything quite well, and that it helps protect everything. You know, you play around with this sort of stuff, you want to make sure it's all fused. Now, I have a battery charger here. It's a regular 12 volt to 120 volt, well, 120 volt to 12 volt battery charger for rated for these lithium iron batteries. And we also have our relays here for control, and here's our 120 volt relays. You cannot use these Bosch style relays for 120 volts, so we just incorporated some 120 volt rated relays here. This is a 250 amp rated relay, I guess, and that's what we're using to turn on and off the inverter. So if we turn this on, we get our cooling fans and the inverter turns on. So one of the nice things about the cooling fan setup that we came up with is it channels the air through the inverter. The airflow is this way, and that allows everything to stay nice and cool. We shouldn't have anything overheating with the inverter. One nice side note is the back of the PACKOUT case actually stands off the ground a little bit, so if you stand this thing on end, you still get good airflow. So that was a nice pleasant surprise. Kind of was a little worried about that, and then I saw how the PACKOUT case sat, and that kind of everything fell into place type moment. We got our outlets mounted here. We have our inlet plug here. Here's some control switches, and then over here, let's see if we can get that in frame. Here's our remote control block that just gets 12 volt power, and it has the load side. Here's our USB charge, our 12 volt outlet for, you know, smaller amp capacity, and our 20 amp 12 volt plug. So that's really everything that's inside, and we can kind of go over how everything's wired. I added some diodes to help protect things and whatnot, but really sounds pretty basic and simple, because it really is. It just crammed a whole bunch of stuff into a PACKOUT, and I think I'm going to be really happy with the versatility of the case. The case does have some gasketing around it and what have you, so that makes that kind of nice. Obviously, if this thing with these fans, it's not going to want to get submerged or be in the you know, a downpour or anything like that, but it's just a little extra protection, so it's kind of nice. And the versatility of having it that you can put in a PACKOUT stack, you know, and the cases are durable, so that's one nice feature there. So on the inside of the lid, nothing super special. We popped out this surround. This just comes out pretty easy with a screwdriver, and we put some bolts here, some eye bolts, some bent eye bolts, and we hung our 2 remotes for the remote control there, so it stays with everything. And we taped in a copy of our drawing of how this thing's wired. So in future, if anything's goofy, we need to replace a fuse, anything like that, we know how we wired it. And this is basically an overview of everything that's in here and how it's wired. So there's our 120 volt in battery charger. There's the switch for the battery charger, 5 amp fuse to the batteries, and that's there for protection of the charger. So we don't want to, you know, do anything there. Now that does backfeed through this 50 amp fuse, because this 50 amp fuse feeds this fuse block, and you can kind of see that all these are after this 50 amp fuse. 70 amp fuse directly feeds this relay, which feeds the inverter, and then the inverter obviously has its 120 volt out. Here's our protection diode for the contacts in this relay, and through here we have some fans with a 1 amp fuse here, and they turn on as soon as this inverter is turned on. So we turn on the switch for CR1. This is CR1. We turn on the switch for that, and the fans that you'll hear immediately turn on. So everything's fused, protected, and here's our inverter on switch. Control relay 1. There's the protection diode for that. And then in order to get the 120 volt outlets, we also have, and you don't know if you won't see them, but there's you'll hear them. We have a bypass switch here, which will pick up control relay 2 and 3. That's what the 120 volt relays are. And then we also have the remote control can come through and energize CR1 at 2 and 3, not 1, just 2 and 3. The remote control has its own fused here, and it's on with the USB charge and voltmeter. I went with the voltmeter just so I can kind of keep track of the voltage level. I know these have battery management, but I personally just wanted to have a visual indication. So that was why I wired that together, because if I'm in the remote situation, I want to be able to see what the voltage is externally. So that's just my own preference. You can do however you want if you decide to build one of these. Other things we have here is control relays for the 12 volt outlets. Here's the switches for them. 1 amp fuse, safety diodes for the coils, and that really just protects this switch's contacts. So when you turn off the relay, it doesn't arc back and shorten your switch's lifespan. Down here we can see the result of that. This is CR1, the 12 volt receptacle. Here's our 20 amp fuse right here for the older style plug, and then right here we have CR5 10 amp fuse for our automotive style plug. So that's a basic overview of what it is. We'll run through some other stuff of how we built it, a little bit about layout, my own spin on designing. Everybody has their own spin to those things, and everybody needs to find something that works for themselves. I'm just going to run through some of my process, so maybe it helps you. Because while all this may look rather complex and intimidating, there's really not a whole lot of complex anything in it, really. It's pretty simple. It's turning everything on and off and following a process. So a little bit of things here and there could have been done a little bit more eloquently, probably. Could it have had a few things done differently? Yeah, I definitely think so. Again, it's the first one I made, so, you know, learning curve. You see some other stuff and have some other ideas. So, I mean, that's the nice thing about working on things. You gotta start somewhere to continue. So there we have it. What can we say? This was a fun project to do. This is the last video in our series. If you guys had any other experiences or anything like that, maybe somebody else built something similar to this, let's talk about it in the comments below. This was super fun. I enjoyed this. I think I'll get some good use out of this thing. It's designed to a purpose. It's not high current, yeah, but for the size that I have here and everything and the batteries, I wasn't going to get a high current inverter crammed into this box. So this was kind of an experiment to see what we could do. Put a whole bunch of parts together, and hey, we got something that worked. So it was a whole lot of fun. I hope you guys enjoyed the series. We're looking to do a bunch more stuff like this in the future. Thanks for watching. Have a great day.